So this is a review video going through the topics that we've done in the coordinate geometry unit just for your upcoming test. So we're going to start with equations of lines. So the only two big things that you need to know are that parallel lines have the same slope and that perpendicular lines have negative reciprocal slopes. And we'll talk about perpendicular in a second. But for number 8, and this is number 8 on page 41 of your packet if you want to follow along, write the equation of a line parallel to 2x plus 3y equals 4 that goes through the point 2, negative 6. Well, to write the equation of a line, we need at least two things. We need a point on the line, and we need the slope. Because it's always easiest to plug into point-slope form, which, if you remember, is just y minus y1 equals m, or the slope, times x minus x1, where that x1, y1 represents any point on your line. So if it's parallel to this given line, that would mean that it would have to have the same slope. But the problem is, this line isn't in slope-intercept form yet, or y equals. So there's a little bit of work we got to do before we can get to that point. So I'm going to subtract 2x on both sides to get 3y equals minus 2x plus 4. Notice I put the x term in the front just because that's how we're used to seeing it when we solve for the equation of a line. And I'm going to divide by 3, and divide by 3 to get y equals negative 2/3 x plus 4/3. Remember, the slope is always the number next to the x when you're in slope-intercept form. So that negative 2/3 right there is the slope of the line they give me. And if I want to write the equation of a line parallel to it, I'm just going to take that same slope. So I'm going to start plugging into point-slope form. Y minus a negative 6 would just become plus 6 equals my slope, which is negative 2/3, times x minus my x-coordinate of the point is just 2. So this would be the equation of that line in point-slope form. If you wanted to get it to slope-intercept form, or that y equals mx plus b, you could always distribute it out, this negative 2/3 over here, and then subtract 6 on both sides. But I'm not going to do that for this example. So for number 9, if they're asking for the equation of a line through a given point that's perpendicular to a given line, the only thing that changes is that instead of taking the slope of the line they give me, we're going to take the negative reciprocal slope. So remember, negative reciprocals just means to flip the fraction and negate it. So in this case, the slope of the line they give me is 1/2. So the slope of the line perpendicular to that is going to be negative 2/1, or just negative 2. So I'm going to plug into point-slope form again, that y minus y1 equals m times x minus x1. And that's just going to turn into y minus 2 equals negative 2 times x minus 4. And this is a perfectly acceptable response if they ask for it in point-slope form. But sometimes it is more useful for us to get it into slope-intercept form, or that y equals that we're used to. So you can distribute the 2 to get y minus 2 equals negative 2x. Negative 2 times a minus 4 becomes plus 8. And then you could add 2 on both sides to get rid of that minus 2 on the left-hand side, to just get y equals negative 2x plus 10. And this equation right here, or this equation right here, are both totally acceptable answers for the equation of a line that's perpendicular to the given line that goes through 4, 2. The next one I want to talk about is a median question. So for number 14 on page 42, they tell me the vertices of triangle ABC are at negative 1, 1, 5, 3, and 1, 4, and they want me to find the equation of the median from C to AB. So in order to do this, you need to know that the median goes to the midpoint of the opposite side. So I'm just going to sketch my triangle right here. Doesn't really matter what it looks like. So A, B, C. And it says it wants the equation of the median from C, so from this vertex right here, to AB. So it's going to come from C and go to the midpoint of the opposite side. So there's a couple things we need to find here. Remember, we always need a point and a slope if we're finding the equation of any line. And it looks like the point that we could use here is either C or this M right here. But in order to find this M, we need to first find the midpoint of AB, and we could find that using the midpoint formula. And then to find a slope, we're just going to find the slope between C and M. And we could plug into the slope formula to find that. So I'm going to start with the midpoint of AB. If you don't remember the midpoint formula, that's just the average of the x's. So x1 plus x2 divided by 2, comma, the average of the y's. y1 plus y2 divided by 2. So in this case for A and B, that's going to look like negative 1 plus 5 over 2, and 1 plus 3 over 2. Or when you simplify that, negative 1 plus 5 is 4, 4 divided by 2 is 2, and 4 divided by 2 again is 2. So this is the midpoint, or that point M, right there. Now the next thing we want to do is we want to find the slope between the vertex C and M. So we always use M to represent slope, and I'm just going to write it as a little cm right next to it, so I know I'm finding the slope between C and M. And remember, the slope formula is just y2 minus y1 over x2 minus x1. So the change in y over the change in x. So in this case, I'm going to make it 2 minus 4 over 2 minus 1, where those are the coordinates for C and those are the coordinates for M. So 2 minus 4 is just negative 2. 2 minus 1 is just 1. So the slope in this case of CM is just negative 2. So again, I'm going to plug into point slope form now that I have a point on the line, even though you could also use point C because point C is also going to be on the line. And I have the slope between the midpoint and the vertex. So y minus y1, I'm going to use the midpoint here, 2, equals my slope, negative 2, times x minus my x coordinate is 2. This is one equation you could have. Or if you choose to use the coordinates for C, you could do y minus 4 equals negative 2 times x minus 1. And this is the same exact process, only you're plugging in the coordinates for point C. Both of these equations, when you solve them for y, will get you the same equation of the line. The next one I want to look at is number 2 on page 43. Write the equation of a perpendicular bisector of negative 2 comma negative 3 and 4 comma negative 1. So we know we need the equation of a line, so it's going to be in point slope form because that's the easiest to put it into. And there's two things we need there. We're going to need a slope and we're going to need a point. So in this case, there's a couple things you need to unpack from this question here. Perpendicular lines have negative reciprocal slopes. So to find the slope, we could find the slope between this point, and then just take the negative reciprocal of that, and that would be the slope of the line perpendicular to it. So I'm going to start there. So y2 minus y1 over x2 minus x1. So negative 1 minus a negative 3 becomes plus 3. And 4 minus negative 2 becomes plus 2. So that becomes 2 over 6, or 1/3. So that's the slope of the segment that they give me. But if I want the slope of the line perpendicular to that, I just need to take the negative reciprocal. So the negative reciprocal of 1/3 is just -3. So that's the slope we're going to use when we plug into the equation. So we've got the slope, but now we need to think about what point we could use for point slope form here. So we took care of the perpendicular part, but remember a bisector is something that cuts another thing into two congruent parts. So in this case, if you think about a perpendicular bisector, when that line cuts through the segment they give us, it has to go through the midpoint to make the two parts on either side congruent. So if we could find the midpoint between those 2 points, we'd be good. So I'm going to plug into the midpoint formula again. So remember, that's the average of the x's comma the average of the y's. So -2 plus 4, I'm adding the x coordinates, and -3 plus -1 or just -1. I'm adding the y coordinates. So -2 plus 4 is 2, divided by 2 is 1, and -3 minus 1 is -4, divided by 2 is -2. So here's the point we're going to use. That's the midpoint of the segment. So once we took the slope, then took the negative reciprocal, that takes care of the perpendicular part, and then find the midpoint, that takes care of the bisector part, you can just plug straight into point slope form. So that's going to look like y minus -2 or plus 2 equals my slope times x minus 1. And again, this is point slope form. If you wanted to put it into slope intercept form, you could always distribute that 3 and then subtract 2 on both sides. The next one I want to look at is number 8 on page 44. If the midpoint of segment CD is 1, -4, and the coordinates of C are 4, 2, find the coordinates of point D. So I'm going to sketch a little picture just to see what we have here. So C, there's some endpoint D over here, and they tell us the midpoint. So the coordinates for point C are 4, 2, and the coordinates for M are 1, -4. And they don't tell us what D should be. So there's a couple questions you need to ask yourself. What formula could I use to help me solve this? And if they're talking about a midpoint, that's going to be the midpoint formula. So if you're looking for x, y here, because those are two arbitrary points we don't know yet, you could just plug into the midpoint formula where you take the average of the x's. So 4 plus, in this case you'd have to use x because you don't know what it is, divided by 2, comma 2 plus y over 2, and then you could set this equal to 1, and you could set this equal to -4, and solve both those equations. But there's a little bit of an easier way to go about this if you could look for the patterns. So the way I do these is I look at my x coordinates, and from 4 to 1, I went down 3. So if a midpoint creates two congruent parts, to get to my other x coordinate, I would also have to go down another 3. So 1 minus 3, my x coordinate would have to be -2. And I do the same thing for my y's. So from 2 to -4, I went down 6. So I would have to go down another 6 to get to my next y value. So -4 minus 6 is -10. So in this case, the coordinates of D would have to be -2, -10. And again, if you wanted to use the equations to do that, you're more than welcome to, but sometimes this process might be a little bit faster. Number 9. In the accompanying diagram, it gives me the points of a triangle, and they tell me that AD is an altitude to BC. So remember, an altitude doesn't have to hit the midpoint of the opposite side. It only needs to go from a vertex and be perpendicular to the opposite side. That's the only requirement. So already in your head, if you're thinking about perpendicular lines, you should be thinking about negative reciprocal slopes. Because for part A, it asks what's the slope of AD, or the slope of that altitude. Well, we could do the same thing we did when we were finding the perpendicular bisector, where we could find the slope of BC, or the side opposite to it, and then just take the negative reciprocal. So, -1 minus 5 over -3 minus 5 is just -6 over -8, or +6 over 8 because the two negatives cancel, or if you reduce, just 3/4. So the slope of the line perpendicular to that is the negative reciprocal, so -4 over 3. This is the slope we want if we're talking about the altitude, which is perpendicular to BC. So to write the equation of the altitude, we just need one point that's on the altitude. And in this case, the altitude has to go through point A. So that's the point I'm going to use. So y minus a -2 becomes +2 equals my slope, 4/3, times x minus 4. And that's it. Again, you could always distribute if you want to get it into y equals, but that's enough for our purposes. For number 10, in quadrilateral PQRS, PQ is perpendicular to RS, and the slope of PQ and RS are 3/4 and -8 over x. What is the value of x? Again, you see that perpendicular sign. You should be thinking to yourself negative reciprocal slopes. So if one of the slopes is -8 over x, and the other slope is 3 over 4, in order to solve for x here, all you would need to do is just take the negative reciprocal of the slope they give you and set it equal to the other slope they give you. So -8 over x equals -4/3. And notice the whole fraction was negative there, and I chose the top to be negative. It doesn't matter which one you pick. Usually it's best to make the constants or the numbers without x negative, but it doesn't matter. So to solve this equation, you could do a couple things, but I always like to cross multiply. So x times -4 is -4x, and I set that equal to -8 times 3, which is just -24. Divide by -4, and you get x equals 6. If they told me the lines were parallel, the only thing that would change is that I would set -8 over x just equal to the slope they give me. That's the only thing that would change. So for something like number 16 on page 45, where they tell me that the segments are parallel instead, and they give me the slope of one of them, and they give me the slope of another one, I would just set these equal to each other. So x over x plus 2 equals 2 over 3. And again, when I just have a fraction equal to a fraction, it's usually easiest to just cross multiply. So 2 times x plus 2 is equal to x times 3, or just 3x. I can distribute that 2 to get 2x plus 4 equals 3x. Subtract 2x and subtract 2x to get 4 is equal to x. For number 18 on page 45, this is a triangle proof. So given triangle ABC with those coordinates, prove that it's an isosceles right triangle. So this is a proof where we're going to need a couple formulas to help us out here, where the first thing they tell me is that it's isosceles. So I know it has to have two congruent sides. And remember, to show that a triangle has two congruent sides, you only need to use the distance formula to show that two sides have the same length. And to show that it's a right triangle, you could use the distance formula and plug into the Pythagorean theorem, but it's easiest to show that two sides have negative reciprocal slopes, because that would show that there's a right angle formed by the perpendicular lines there. So I'm going to start with the isosceles part. So if you don't remember the distance formula, remember that's just d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm going to find the distance of all the sides and hope the two of them are the same. So I'm going to start with AB. So the distance between A and B would look like 1 minus negative 4, or plus 4 squared, plus 8 minus 3 squared. And that simplifies to radical 5 squared plus 5 squared, or radical 50. And I'm not even going to simplify in this case, because if another side is congruent to AB, then I should get radical 50 somewhere else in my calculation. So I'm going to do the same thing for the distance between B and C. So the distance between B and C is equal to the square root of, subtracting my x's, 6 minus 1 squared, plus 3 minus 8 squared. So I get radical 5 squared plus negative 5 squared. But remember, negative 5 times negative 5 is going to become positive anyway. So that's 25 plus 25 equals radical 50. Okay. So that's enough work to justify why this is an isosceles triangle, but we still need to show why it's a right triangle. So I'm going to do that by using the slope formula. So I'm going to find the slope between each of the vertices and hope that two of them are negative reciprocals. So I'm going to start with the slope between A and B. So subtracting my x's and subtracting my y's. 1 minus negative 4 is just 1 plus 4. So that's 5 over 5, or just 1 over 1. I'm going to leave it as a fraction so that I could see whether or not it's actually a negative reciprocal. I'm going to find the slope of BC next, and that's just going to look like 3 minus 8 over 6 minus 1, which gets me negative 5 over 5, or negative 1 over 1. So in this case, sometimes it's a little bit hard to see with these. But 1 over 1, if I flip that, it's just 1 over 1. And if I negate it, then one of them would have to be negative. So in this case, the slope of AB and the slope of BC are in fact negative reciprocals of each other. So this is enough work to justify why it's an isosceles right triangle, but it wouldn't be enough of an explanation. So you'd have to write a little blurb here about why your work proves that it's an isosceles right triangle. So you could say something like, when you plugged into the distance formula, you saw that two sides were the same, therefore it must be isosceles. And when you plugged into the slope formula, you saw that two slopes were negative reciprocals of each other, therefore AB is perpendicular to BC. Therefore, angle B is a right angle, making triangle ABC an isosceles right triangle. And if you wanted to prove that it's a scalene triangle or a equilateral triangle, you would just do the same sort of process where you would use the distance formula, show that no sides are congruent, and you would use the distance formula to show that all sides are congruent. The only time we really use the slope formula is when we're looking at right triangles and we want to show that there are perpendicular lines there to form right triangles.